Okay, quotient rule to solve a problem. So the question is asked us to find where the line is when the tangent to this function is horizontal. Okay, our function is f at x is equal to 2x plus 8 divided by root x. We got to find out when this is horizontal. So in other words, we want to find when the rate of change is 0. Now in order to find out rate of change, we need to derive our function. So we need to find the derivative of this, our f at x, or in our case f prime x we're looking for. And again, I'm going to denote this. We'll call this g at x this time. And we'll call the bottom h at x in our quotient rule. So we know with our quotient rule, we take the derivative of the function that's on top. So we derive 2x plus 8, in which case we're going to get 2. And we multiply it by the original function on the bottom, which is h at x. And in this case, that's root x. Then we subtract it by the original function on top, g at x. In this case, that is 2x plus 8. And we multiply that by the derivative of the function that was on the bottom. Now, this one's a little tougher. This is a root. So technically, we'll do this in blue over here, we're at x to the half. When I derive that, we're going to get a half x over a half, and technically those aren't equal, so I won't write that. Okay? And I can rewrite that as 1 over 2 root x. Okay? Because our half's at the bottom, and we know we can take a half is a root. I mean, if it's negative, we just put it on the bottom of the fraction. So I've now rewritten this to be 1 over 2 root x. Okay? And all of this is technically above the original function that was on the bottom, which is our root x, and it's squared. Okay? And that's where our h at x squared is. H at x squared. So there's our quotient rule in red and green, just around it. So we're going to try to simplify this a little. Our f prime x. This is going to leave us with 2 root x. Subtract, and because this is like multiplying a fraction across, we'd get 2x plus 8 divided by 2 root x on the bottom. Now, because we are subtracting these terms, and of course let's write what's on the bottom. We'll get to it in a second. Root x squared is just going to be x on the bottom of the equation. Okay, so we have that. Now, because we have to subtract these, and these are both fractions, we need a common denominator. Right now, this denominator is 1. So in order to get a common denominator, I'm going to multiply the first term by 2 root x. The top and the bottom, 2 root x. Okay. What we're then going to get from there is we're going to get 4x. 2 root x times 2 root x is 4x. Subtract 2x plus 8. And I'm putting it all over one denominator because they were common. Our common denominator was 2 root x. And again, that is technically divided by x. So it's like we got a triple stacked fraction here. We don't like the way this looks, so I'm going to rewrite it. 4x minus 2x plus 8 divided by 2 root x. And we know we can invert this, right? Because this is divided by x, I can flip this and make it a multiplication question. So we get 4x minus 2x plus 8 divided by 2 root x multiplied by 1 over x. Okay. So when I multiply by 1 over x, we're going to end up with 4x minus 2x plus 8 divided by 2 root x, and technically this is times x. So right now what we have is we can't actually, though it looks very close, we can't actually combine these here because this is the root of whatever this term is. So there's not much we can do there. But this 2 on the bottom, because it's multiplied by, I can actually divide each of the terms on top by the term 2 on the bottom of this question. So when I take that out, this will become a 2, this will become a 1, and this will become a 4. So we'll then be left with 2x minus x plus 4 all above x times root x. And then we can collect our like terms. Could have done that in the last step technically. And we'll be left with x plus 4 over x root x. Now, I have a positive and they have a negative. Yes. I apologize. Let's return. This negative term should be applied to both of these. So yes, this should have been negative 2x, but this should have also been negative 8. Small mistake. So because that should have been negative 8, that makes this and this negatives. And finally, we should have x minus 4 in the end, not plus. Small error. Process is the exact same though. Okay? So x minus 4 over x root x. And now they said they actually wanted, what did they want in this question? Find where the horizontal is tangent. So, in other words, we're looking for the rate of change being 0. So we take our equation, our derivative, and we set it equal to 0. Okay? Well, when will this be equal to 0? Well, we know we don't want the bottom of the equation to be equal to 0, so we just take the top. 0 is equal to x minus 4. When x is equal to 4, this equation should be 0. Now, we should double check just to make sure if we plug 4 in the bottom, it doesn't become undeterminate. Well, we know 4 times root 4 is actually going to be 8. So it works out perfect. So in other words, this function will be horizontal, or tangent will be 0, excuse me, when x is equal to 4. And if they need the exact point, okay, we know that the slope at this point, when x is equal to 4, we know our slope will be 0. If they need the exact point, we take 4 and we plug it into the original equation. So let's do that. We're going to take f at 4 is equal to 2 times 4. This is our original equation with 4 plugged in over root 4. This will give us 16 over 2, 8. So if they need the coordinate, our x value is 4 and our y value is 8 when our slope is 0. That's when we are turning, okay? Our equation is probably turning.